Okay, here's a slightly more complicated absolute value problem. So we're looking at this, and we have the absolute value of this expression is equal to some other expression. Now we just can't throw the absolute value away. So let's think about what we know. So let's agree, this is, I think, kind of obvious, that 4x plus 5 equals 4x plus 5. Do you agree with that statement? So remember that this is our distance here. Absolute value is equal to distance. So I'm saying this distance is equal to this distance, correct? So let's just say the absolute value of 4x plus 5 is equal to 4x plus 5. Well, remember what we also know about absolute value. So let's just think back that we knew that the absolute value of negative 5, for example, equaled 5, and the absolute value of 5 equals 5. So we're going to take this concept so I can think, notice how this is the opposite of this. So what's the opposite of this? Well, that would be negative of that whole expression, or the opposite of that whole expression. That also equals 4x plus 5. What would that be? That would be negative 4x minus 5x. Absolute value is the same as 4x plus 5. Okay? So I'm going to rewrite that again, and we're going to think about this idea and this idea right here. So this is what we're going to keep in mind when we do case 1 and case 2. So we have case 1, and we've been using case 1 as whatever is inside is positive. So we know that 4x plus 5 has to equal 4x plus 5. That's what we're thinking to help us set up case 1. For case 2, we're going to think of, well, the negative, or the total opposite of this, which I just showed you when we figured it out, when we took the opposite of this number, we get negative 4x minus 5. So that's the absolute value of negative 4x minus 5. That absolute value is equal to 4x plus 5. Okay? So we're going to use that concept to help us set up case 1 and case 2. So let's look at case 1. Case 1. So the 3x plus 2 is inside our absolute value, and our 4x plus 5 is also inside the absolute value. So that means I know that 3x plus 2 is equal to 4x plus 5, because whatever's inside has to equal whatever's inside. So let's look at case 2. This negative 4x minus 5 is inside the absolute value, and this 3x plus 2 is inside the absolute value. So that means case 2 is negative 4x minus 5 is equal to, excuse me, yes, let's write it the other way. Sorry, that means that 3x plus 2 has to equal negative 4x minus 5. Okay? Because this is inside the absolute value, that comes here. This is inside the absolute value, that comes here. So that means we have our two cases set up. So now all we have to do is solve. So when I'm looking at this problem, I'm thinking, I either want to get x on one side or the other. Because 4x is a larger positive number than 3x, I'm going to move the 3x over to the other side by subtracting it from both sides. So that gives me 2 is equal to x plus 5. Now I want to get x by itself, so I'm going to subtract 5 from both sides. So that gives me negative 3 is equal to x. So that's one possible answer. Okay? So let's look over on this side. Oh, look at this is negative 4x. I don't like negative numbers. I'd rather have a positive number. So I know when I add this, I'm going to get a positive number. You don't have to do it that way. It just saves you from having to divide by negative or having to move numbers again. It's less work. So this gives you 7x plus 2 is equal to negative 5. I'm going to subtract 2 from both sides because I want to get my x term by itself. So that gives me 7x is equal to negative 7. And if I divide by 7, that gives me x is equal to negative 1. Okay, so in the last couple problems we checked by substituting it in, we checked by looking at distance from center. And this particular problem tells us specifically to check for extraneous solutions. So remember, extraneous means it's something that is not true. Okay, it's an answer that when we worked it out, we definitely got 2 answers, but maybe one of those answers is lying, which means we have to put it back into the original. So our original problem was the absolute value of 3x plus 2 is equal to 4x plus 5. So we're going to substitute negative 3 in first, and then we'll substitute in negative 1. So the absolute value of 3 times negative 3 plus 2 is equal to 4 times negative 3 plus 5. Notice, x is negative 3. So negative 3 gets substituted in everywhere I see an x. What's important to remember is when we're testing, our answer is to not cross the equals sign. So then this becomes the absolute value of negative 9, plus 2 should equal negative 12 plus 5. And this gives me the absolute value of negative 7. Does that equal negative 7? Well, wait. Let's think a minute. We're saying the absolute value of a number equals a negative value. Can an absolute value be negative? The answer is no, because absolute value is the measure of distance. So we know that the negative absolute value of negative 7 should equal 7, but that's not what we got. We got negative 7, right? So this answer is extraneous. This answer right here is extraneous, which means it's not an answer. That one is not going to work because the absolute value of negative 7 will never equal negative 7 because distance is always positive. Okay, well let's check with negative 1. We're going to do the same thing with negative 1. Our original equation was the absolute value of 3x plus 2 is equal to 4x plus 5. Let's substitute that back in. So that means the absolute value of 3 times negative 1 plus 2 equals 4 times negative 1 plus 5. Remember, wherever I see an x, I'm going to substitute in negative 1. So that means I have the absolute value of negative 3 plus 2 is equal to negative 4 plus 5. Negative 3 and 2 is negative 1. So that's the absolute value of negative 1 equals negative 4 and 5 is 1. Well, the absolute value of negative 1 is 1. So this is in fact our only answer, x equals -1. So I do not think we have to graph this, so we're done with that problem.